Okay, so today we are going to do piecewise functions and greatest integer functions. Okay, piecewise and greatest integer. So we're going to start off with piecewise. Y'all, this is an algebra 2 skill. Piecewise is an algebra 2 skill. Greatest integer is not, but the way I'm teaching it, it is. All right. So on your piecewise functions, what do I want to see? Well, I want to see your graph, okay? And I want to see a T-chart. On your T-chart, I want 2 points in each section. We will divide our graph up into sections, hence the word piecewise. Each piece, okay? The second thing, they must have the endpoints. Okay? Must have the endpoints. They will lie on the break lines. Let me shut this door. They will lie on the break lines, which we will draw. And they must be graphed. Have to graph the endpoints. Okay? Have to graph the endpoints. All right. So let's start with our first problem. F of x is equal to. You can divide these piecewise functions into as many things as you want them to. The two that I'm fixing to work are just divided up into two things. So this one is 2x plus 3 when x is less than or equal to 1, and negative x plus 4 when x is greater than 1. Okay? I'm going to draw me a big graph over here.
What?
Okay, and I'm going to make a T-chart. So on my T-chart, I want any endpoints that lie on a break line, okay? And then every section has to have at least 2 points. It could be in between 2 break lines, that would be okay. Or if there's not another break line, then it just needs another point to tell me what's going on. I'm going to show you the way I do it. It is not the only way to do it. I mean, the easiest thing to do would be to graph this line right here, and then get your big giant eraser and say this line only exists less than or equal to 1. So erase everything to the right side of 1. That would be the easiest way to do it, okay? But, I mean, actually, I don't think it's the easiest way, but it's one way, okay? So your break lines are always going to be wherever these numbers are. I'm going to make it a dotted line, and I'm going to use a highlighter, simply because it's not an asymptote. I don't want to use the same pen that I'm graphing with, because then when I draw a dotted line, I tend to think it's an asymptote, and it's not an asymptote, okay? It's actually just a line that says, whoa, watch it. Something's fixing to happen here. This left-hand side of this graph is going to look different from this right-hand side of the graph, okay? So that's why I graph mine with this highlighter. It's really not part of my graph. It's just kind of a gentle reminder to me. Okay, so here's what I do. I like to put these lines where they belong, okay? So this line right here exists on which side of that dotted line?
The left side.
The left side over here, where x's are less than or equal to 1. And that would be on this side, okay? So y is equal to 2x plus 3. This other line right here, he exists where the x's are greater than 1, so that will be to the right of that line. So y is equal to negative x plus 4. Let me make sure and warn you about this, okay? Because this is what they do a lot of times. They'll keep them like this and put the one on the left first and the one on the right second. And they'll do that for about 3 problems, and then they'll flip it just to see if you're paying attention, okay? So don't just assume that the first guy goes on the left. You read his restriction, he tells you where he goes, all right? So look at this line right here. What is my slope?
2.
What's my y-intercept?
3.
So I'm going to my y-intercept, okay, and which is 3, and I'm going to make a dot. Can I put that dot on my T-chart?
Yes.
What is it?
3, 0.
What?
0, 3.
Yeah, 0, 3. All right? I'm going to use my slope, which is 2, and I'm going to go up 2 and to the right 1. I am on this dotted yellow line. Is it a solid point or a hollow point?
Hollow point.
Solid.
See that or equal to
Oh, yeah, it
line?
is solid.
That means
I
he's
bet.
included. So that's a solid point. Can I put that
Yes.
in my T-chart?
Yes.
What is it?
1.
1, 5. Here's my graph. Okay? Now, here's what I would always do. Look at my slope, it's positive. Does this line have a positive slope?
Yes.
What tricks, kids?
And down that road.
Yeah, the kids see that down arrow and they're like, no, that thing's going down. No, people, it goes down forever, but if you read the line from left to right, you're actually going up. So he does have a positive slope. Be careful with your slopes, okay? Slopes are, if you have a problem, you're generally with the slope. All right, look at this guy right here. What's his slope?
-1.
And what's my y-intercept?
4.
Okay, so I go over here to my y-intercept of 4. 1, 2, 3, 4. Can I make a point?
No.
No. People, this line only exists to the right of that dotted line. So can I use this point to graph or to start my graph? Yes, I can. I just can't make it yet, okay? My slope is -1, so from this positive 4, where do I go?
Down 1.
Down 1 and to the right 1, okay? It's here on the yellow line.
Okay.
Solid dot or open dot?
Open.
Open dot. Okay? Can I put that on my T-chart? I can. Okay, and what is it?
1.
1, what? 3?
3.
Okay. So I'm going to use my slope again. I'm going to go down 1 and to the right 1. Can I put that point in my T-chart?
Yes.
And that is
2, 2.
2, 2. And I can draw my line. Does it have a negative slope?
Yes.
Yes, when you read the line from left to right, he's going down. All right? So, did I meet all the requirements? Do I have 2 points in each section? Yes. Here's 2, and there's 2. Okay? Anybody have a question?
Yes. So you did like an open dot for the first one on the second.
Right here?
Yes.
Because he's
then-
not an or equal to. If it has an or equal to line, then that's a solid dot. If it
Okay.
doesn't have an or equal to, this means that this line exists, everything greater than 1. Not equal to 1, but everything to the right of 1. This says he exists to the left of 1 and including 1. So I included it and all the way to the left.
So one was not included, so you did an open dot, but anything to the right of it,
Is
you can do
included.
a solid dot.
Right, because he does exist to the right. Where is this line? Where x is greater than 1. Is this, on this point, is x greater than 1? No, it's equal to, so he doesn't exist there. But everything to the right. Y'all listen to me. This is what Bailey's asking me, because this is what happens all the time. Kids put a hollow dot here, and so then every time they put a point, what do they put?
A hollow dot.
Y'all, the line exists to the right. Don't do that. That's crazy, okay? Because when you put a hollow dot, you just made that function not exist right there, and that's not true. Okay? So you missed it. All right? And here's another question. What if I have a hollow dot and then I have a solid dot inside that's on top of it? What does it look like?
A dot.
Yeah, people, it looks like, this is what it looks like, okay? This is not what it looks like. I call it owl eyes. Alright, that's what kids do.
When would that happen?
This never happens. This is no, I don't know. That's spooky. I don't like that. Okay? This is, if you have a hollow dot and I put a solid dot on top of it, it just looks like a solid dot. There's nothing squeezing out underneath it going, oh, I'm a hollow dot, he's squishing me. No, it's just a solid dot, people.
What if you have a
Okay.
solid dot, then you put a hollow?
Then guess what it looks like?
A dot.
A solid dot.
Okay.
Okay? So if they're both in the same place, it just looks like a solid dot. Alright? When would that happen? That would happen if they both ended on the same point on one of those break lines. Okay? If they both had the same, now listen to me, does that make sense? I mean, look, could both of these dots be solid? If both of these dots were solid, would that be a function? What does this say? A function of x, okay? He's telling you, hey man, this is a function, okay? Then one of those common mistakes is for kids to take and they draw their lines, like they'll draw this line, the whole entire thing, like this. Come here, pencil. Like they'll draw this line like this, and I'm like, what in the world, people? Is this a function?
No.
But this is not a, he doesn't pass the vertical line test, okay? As soon as you're hitting the top line and the bottom line. Okay, if you're gonna draw the whole entire line, then you erase the part that line only exists to the right of one, so you erase it everywhere to the left. Okay, it's a function, it has to pass the vertical line test. Everybody okay? Do y'all remember these from Algebra 2?
Yes, ma'am.
Okay, so we're gonna do one more, and then I'm gonna explain to you what the greatest integer function looks like. Okay, so here's my second one. Okay, so before I put this one on here, I'm gonna warn you about what they're fixing to do. After this test, we're going to have a 50-point memory test. They're fixing to make it relevant to you, okay? They're fixing to say, you're gonna be like, what? Oh my gosh, I forgot all that. No, you can't forget all that. So I'm gonna give you after we finish this test, then I'll give you a form and we'll fill it out together, and then I'll give you a few days and we'll have a 50-point memory test.
Is it that long sheet of paper
Mhm.
of the different graphs?
Yeah, for the 13 different graphs, the 13 different types of functions. You'll have to know the name of the function, the graph, the equation of the parent function, and the domain and the range, okay?
I can pass.
So, that'll be a 50-point test, all right?
Is that on this 6 weeks?
Yes, it will, that's exactly what it is, all right? Here, let me see it, baby. Let me see it so I can, I'm gonna show y'all. This is what it is.
I'm an algebra nerd for you.
See this right here?
I remember that. I did good on that.
So why does Bailey have it? Because we did it where?
Last year.
Last year in Algebra 2, okay? But we stopped at logarithmic. Now, look at there. Greatest integer function, that's what we're fixing to talk about. Sine, cosine, and tangent functions, okay? So we took the 9 and we added 4 to it, and that gives you 13, okay?
Wait, 9 plus 4 is 13, Ms. Davis.
Oh, I'm on it today, aren't I? All
Y'all
right,
keep y'all's algebra notes?
Yeah, I guess.
I'm pretty
okay,
proud.
so here we go.
Mine are ashes in my backyard.
In ashes, yeah. I burnt
F
those.
of x is equal to 1 minus x minus 1 quantity squared when x is less than 0, and the square root of x minus 2 when x is greater than or equal to 0. So, draw me a little graph over here. I'm gonna do the same thing, guys. I'm gonna put my equations where they go, because that makes me know where to draw them. We're gonna see how much of your algebra 2 you remember, okay? So, I'll make me a little T-chart down here, because I know what has to be in it. At least 2 points of any section, okay? Where's my break line?
Zero.
0.
0, okay, so I'll draw it on there. Put your phone up, you got a phone out. I hate to call you out on YouTube.
And they'll always be like the same breaker, or will there be different ones?
Oh, well,
Negative.
I could
Still
put,
getting nothing.
he wasn't the only one. I could put,
I'll give it
like there could be 3 sections, okay? And if there are 3 sections, then obviously I would need 2 lines to divide it up into 3 sections, okay? But yes, they will always be the numbers that are over here, okay? Always vertical lines with those numbers. So, I got him at 0, so I'll write this, where does this equation go? To the left. Watch the way I'm gonna write this equation, because I don't like the way it's written here, okay? So that's not the way you're accustomed to seeing it, so y is equal to negative x minus 1 quantity squared plus 1. Is this the same as this?
Yes.
But this looks better. I look at that and I go, what? That's a quadratic, okay? That's a parabola. This guy right here, x is greater than or equal to 0, he's a square root function. If you remember that little test, then you know what he looks like. If not, it'll be a little bit harder for you,
No clue.
okay? Alright, so here we go. Let's do this one. This is a parabola. Do you agree with me?
Yes.
Okay, what does this minus do to my parabola?
Flips it.
Yeah, he makes him open down. Instead of opening up, he reflects him over the x-axis and makes him open down. What does this minus 1 do?
Takes you to the right.
Takes you to the right. So here are the rules, right? If you don't remember the rules, here they are. If you are with an x, you are an x, and you move it left or right, opposite of what you think. So minus 1 goes to the right one, all right? If it's not with an x, then it's said to be a y. That's why this is a y. They move it up or down just like you think. So that plus 1 moves it where?
Up.
Up 1. This negative out here is a y, okay? It's actually a negative 1. If that number is bigger than 1, okay, don't think about the negative sign. The negative just makes it open down. The negative actually reflects it over the x-axis. If I put a negative on the inside with the x, he reflects it over the y-axis, okay? So, he reflects it, if there were another number out here besides this 1, then if the number is bigger than 1, it's a vertical stretch, okay? If the number is between 0 and 1, it's a vertical compression. If I put that number in there with the x, then he's a horizontal, and he does the opposite, just like everything else. Y'all, x's are always backwards. So he does the opposite. So if the number is bigger than 1, instead of it being a horizontal stretch, it's a horizontal compression, okay? And if the number is between 0 and 1, it's a horizontal stretch, okay? All right, so here we go. This guy right here. So you said he is the parabola. The parent function starts here at 0, 0, and he goes like this, okay? That negative on the outside makes him go down,
Yes.
okay? This minus 1 right here moves him to the right one, and this positive 1 moves him up 1. Can I draw that dot?
No.
Okay, so I'm gonna get my pencil out because I want to erase some stuff. I don't wanna have to keep stuff in my brain. All right, so there's the vertex of my parabola, and he opens down. Now, this is not actually a slope, right? But how many times can I kind of use it like a slope?
You only have to
One
once.
time. Y'all, you cannot use it any more than once, okay? Once you've used it once, then you're gonna have to find points. You'd have to just like say, well, I didn't get it from there, so I'll just have to pick a point over here. Do you understand what I'm saying? So I can use it once. So I can go down and to the left one. I'm now on my line. Is it solid or hollow?
A hollow.
Hollow, not or equal to, okay? Now, how many points do I have in this section?
1.
1. You just got the one that's on the line. That's all I got. I will put him in here, 0, 0. So I have to have another one. People, you're just gonna have to pick a number. I would stay as close to my vertex as I could, okay? Because depending on what this number is out here, depends on how fast it gets really steep or not. I would just pick -1. What am I gonna do with that number? I'm gonna plug it in, okay? So I got the opposite of -1 minus 1. I'm right here. Quantity squared plus 1. What's -1 minus 1?
Maybe 2.
What's negative 2 squared?
4,
What's the opposite of 4?
negative 4,
What's negative 4 plus 1?
negative 3.
So at negative 1, it's negative 3. So this is what my parabola looks like. Got it?
How come you didn't put 1, 1 in the T-chart?
Because he's not in, he's not.
Oh, he wasn't,
He's
he's
not
not less than,
allowed.
okay, I got
Yeah,
it.
he's not in that section.
He's not less than 0.
All right, anybody got a question? Am I okay with this section? Do I have 2 points in my T-chart and my graph looks good?
Yes.
Do I have a point that's on the break line?
Yes.
Yes, he's an open circle, because he's not included at 0. Everybody okay? Okay, so anybody remember what the square root function looks like?
No.
Oh.
Yeah? He looks like this, guys. He's a sideways parabola. Okay?
That's the first one on the paper, that's number 1 on there.
No, it wasn't.
On the 13.
No, it's not. It's like number 4 or 5 or something. I don't know. I gave the paper back to Bailey, but whatever. It's not. Okay, so look at this guy right here. All right, here he is. What does that minus 2 do to that function right here? Moves it 2 to the right.
Yeah.
1, 2. So now he starts right here and he goes. I need another point. Okay? I have to have another point. So let's just pick one. I'll try 3. Y'all, I'm going to be very careful when I pick these points. I'm not just picking any Joe Blow up there, okay? I want to pick something that's going to make a nice perfect square.
1.
Okay? So 3. 1 will not.
No, I'm saying-
1 will be
I'm
imaginary.
saying it's going to make
Oh,
1.
yes, and 1 will be good. So I'm going to pick
6.
No,
3.
it's my bad.
6 would be okay, but I'm going to pick 3. What is 3 minus 2?
1.
What's the square root of 1?
1.
So at 3, he's at 1. So I've got this point. Tell me what this point is right here. I'm putting him in my T-chart.
2,
Very good. Y'all, you better be careful with these points.
Why are you
The-
pointing those if they're not on your break line?
Because he's not going to go to the break line. See how this function right here starts at 0, 0?
Yeah.
When you moved him to the right, there is nothing in here. Okay?
On
Sean.
the test, we have to label each tick mark, or like every 5 of them, I guess.
Will you write the graphs on the test? You have to label the tick mark?
Like, you mean like 0, like 2, 0, or?
You gotta have 2 in your T-chart.
Oh.
You have to have 2 points in this section and 2 points in this
That's not what
section.
he means. He
No,
means
Okay,
like
tell me what he said.
pick marks on the graph.
Oh, do you have to tell me that they're, if you go by anything other than 1s, you have to tell me. Does that answer your question?
Yeah.
Okay. Okay, so if you go by 1s, you don't have to tell me, because I'm gonna assume you're going by 1s, all right? So, but if you go by 2s or something like that, which I don't really like for you to do, so, I would just say go by 1. All right, so this point, tell me what this point is.
3.
2, 0.
What's the common mistake?
0, 2.
Kids are going right, 0, 2, be careful, guys. He's at 2, 0. What's this point right here?
3, 1.
3, 1. Okay, so here's my question. Have I done everything? Do I have both sides, both sections graphed?
Yes.
Do I have 2 points in each section?
Yes.
Do I have points on my break lines that are supposed to be there? I look at it and I go, uh-oh, I only got 1, I'm supposed to have another one, but oh no, that's a
You
weird
can't.
function. Okay, he doesn't go to that break line.
Is he not gonna be negative at all?
No, not unless I pop a negative out here. Then he would go that way. Okay? All right. Everybody okay? Okay, so I'm done with piecewise functions. Okay? So now let's talk about the greatest integer function. I'm going to show you what the parent function looks like. Okay? Because if you can graph the parent function, didn't I just show you that you could graph any of them? I mean, that's what we did here. We took the parent function of the parabola and we did all these transformations on it. We took the parent function of the square root and then we did those transformations on it. That's the same thing. That's the way I'm going to do the greatest integer function. Okay, so it looks like this. F of x is equal to And it's a bracket, but it's a double barred bracket.
What does that do?
Makes it the greatest integer function, okay? Makes it the greatest integer function. It's a double barred bracket. And here's what it means. First of all, you have to know what an integer is. Somebody tell me what an integer is.
Number.
A whole number or its opposite,
Typical.
okay? So what are the whole numbers?
What's the difference?
Whole numbers, what does it start at? What letter does it sound like I'm saying?
Zero.
Oh, whole, yeah, oh, zero, okay? So 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4. All right, so everybody know what an integer is?
Wait, did you-
No what? No fractions and no
Decimals.
decimals.
Wait,
That's what an integer is.
Did you say it was a whole number in its way?
Opposites,
Okay.
okay? A whole number and its opposites. So the whole numbers are 0, they're the counting numbers plus 0. All
Wouldn't
right?
opposite mean
Zero.
like
Negative.
That's
It's
reciprocal.
That's reciprocal,
doesn't,
or multiplicative inverse.
isn't that the
That's
same
not
thing
an
as
opposite, no, an opposite means change of sign, okay? All right, so it is the greatest integer not greater than X. Okay, that's what it means. I want the greatest integer not greater than X. Can it be equal to X? Yes, as long as it's not greater than X, I'm good. Okay, so I'm gonna make me a little graph. I would have put my tick marks really close to each other. Okay, you'll see and learn more if you make them kind of big and exaggerated right now. It's gonna look like this. This is just the parent function. Okay? The greatest integer function. F of X is the greatest integer of X. The greatest integer not greater than X. So, remember when we did parent functions and we just made us out a big old giant T-chart? Okay? I like to always start on the right-hand side because kids are more comfortable with positive numbers than they are with negatives. So I'm gonna start off, and I'll leave me a little space up here to do my negatives. All right? So, I'm gonna start at 0. Tell me the greatest integer not greater than 0.
-1. 0.
0.
Yeah.
Wait,
zero?
Say that again?
The greatest integer not greater than 0. 0. It's not greater than, okay?
So
It's
it's
equal
the
to, but it's not greater than. 0.
Why did you do that like right in the middle?
So she
Because
can do
I'm gonna
negatives
the
and positives.
up here,
Oh.
so I'm just gonna do the positives. Most kids are gonna be more familiar with the positive. And you have to be careful with the negative ones, I'll tell you that, okay? So, I wanted to start you out over here. So at 0, it's 0. Are you with me?
Mhm.
Okay, what about 1/4? What is the greatest integer not greater than 1/4?
1/4.
Zero.
0 again,
What? That's so confusing.
okay? What about 1/2? What's the greatest integer not greater than 1/2?
Zero.
Still 0. What about 3? Now y'all understand that it's all those ones in between, right? I'm just kind of skipping along. Okay, so what, 0. What about 3/4? 0.
Oh, what's the greatest whole number?
Okay? What about 1?
1.
1. Oh. So it's 0 up until what? You get to 1. So it's all of these. It's a solid dot here, and it's all of these until you get to 1. And at 1, it goes up to 1. Are you with me? What about 1 and 1/2?
1.
So it's still 1 right here. What about 2? Oh, so he stays 1 up until you get to 2. And then what does he do? He goes up to 2. And he stays 2 until what?
It gets to 3.
You get to 3. And then at 3, it jumps up to 3. And it stays 3 until you get to 4. and then it jumps up to 4. What does that look like?
Stair step.
That's exactly. This is called the step function. Okay?
I like
This is
it.
called the step function. Why? Because that's exactly what it looks like, people. Okay? Now, I'm gonna kind of start from 0 and I'm gonna go backwards. I'm not really sure which is the best way. I went the other way this morning and I kind of lost a couple of kids, so I'm gonna do it another way. All right? I'm gonna go -1/4. What's the greatest integer not greater than -1/4?
-1.
-1, very good. Not 0, guys, because 0 is greater than -1/4. What about -1/2? What's the greatest integer not greater than -1/2?
-1.
Still -1,
Oh.
okay? So what about -1? I'm skipping over -3/4 because it's -1.
Not greater than
What about
-1.
-1?
-1.
-1. So look what happens. At -1, it is -1, and it stays -1 until it gets to where? 0. And then it jumps up to 0. You see, it just keeps going, guys. Do you see the pattern?
So after you have the pattern, you really just
Yeah, after you got the pattern, man, you're home free. Okay? You're home free. All right, so anybody got a question? Okay, so I think I'm gonna do it a little bit different than I did this morning. I'm gonna do the first one that we do, I'm gonna do it on this graph, but I'm gonna use a pink pen, okay? So that you'll understand what happens. So, this is the one that, I did first, okay? So, f of x is equal to 2 times the greatest integer not greater than x minus 1, and then plus 2. Okay, so before we start, let's get an idea of what's going on, okay? So, are you ready? Are you still writing? Hello?
Yes.
Yes? Okay. I feel like I was texting my kids or something.
Did they not answer you?
When they want money or something, they're texting me, you know, hey mom, could you put $60 in my account? I need dog food and stuff. Okay,
They don't
well,
work?
what happened? I thought you worked, so don't you have money from that?
I bought a mouse to feed to Russell and he didn't eat it.
Silence.
So now we're
Silence.
living
I'm like,
together.
what? Wait, excuse me? Like you're gonna talk to me when you need money, and then when I ask you a question, you're not going to talk to me? I just took the money back out of your account. So, no, come on.
Wait, how old are your kids?
That's just the one that's left in college.
Oh, I was about to say.
Okay, no, the other ones, don't much ask me for money. So, alright, so let's talk about what all the transformations that happen. What does this -1 do to this function?
Takes it to the right.
Takes it to the right one. Does everybody agree with that? What does this +2 right here do to this function? Up 2. Okay? What about this guy out here? First of all, this guy out here, is he a Y or an X?
Why?
Yeah, y'all, he's not in there with an X, so he can't be an X, okay? If he's not in there with an X, he has to be a Y. Okay, so he is a vertical. He's either a vertical stretch or a vertical compression.
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 Okay, so let me ask you this. If you took look, Y's are exactly what you think they are, right? So if you took my height and you multiplied it by 2, would that be a vertical stretch or a compression?
Stretch.
Okay, so this is a vertical stretch, all right? So it's a vertical stretch of 2, okay? What's gonna happen to this thing right here when I vertically stretch it?
It's
Get further apart.
Oh, thank you, Travis. How far apart? 2, okay? So here they're 1 apart. So if it has a vertical stretch of 2, Travis says now they're gonna be 2 apart. What if I put a 5 right here? That'd be 5 apart. What if I put a 1/2 right here?
That'd be a compression.
And then they would be how far apart?
Half.
1/2. Okay? Has everybody got it? Alright, so here we go. Let's do it. Y'all listen to me. When you do a transformation like this, you find one little piece of the graph or point, and you move that one piece or point, okay? I'm gonna always do this guy. You could do whatever you wanted to, it wouldn't matter, but I always try to do the one that's around the origin, okay? So let's take this guy and let's do this, okay? I'm going right 1. So now he's not here, but he's here. Are you with me? Everybody okay? Now what am I gonna do with him? Go up 2. So 1, 2. Now he's right here. Are you with me? He goes like this. Okay? Now, where is his next friend on the right side?
Up to.
Wait, does that become a full dot because we can't have dots?
No,
like
no,
that?
he's just the pink. We're pretending like the black's not there.
Okay.
Okay, it's just the pink. Okay, so where's my next little, what do you call it? This step?
At
My next
4.
step. Yeah, he goes up 2, 1, 2, and he does like this, and he goes like this. Are you with me?
I don't like this.
Okay, now let's go the other way. Where does he go from here?
Down to.
Down 2, and he's this guy. He looks like this guy right here. And then the next one, he goes down 2. 1, 2. So he's gonna be like this. You see him? It's big, tall steps. I wouldn't use these. Okay? Yeah, Sean would be good using these, and I would hurt myself. All right, see them? 2 apart. Everybody got it? Okay, was that hard?
No.
Okay, so let's draw us another little graph down here, and we're gonna do 2 more. In what?
9 minutes.
9 minutes.
Oh, yeah. It ended up being a little bit longer lesson than I thought it would be, but that's okay. If we need to take another day,
We don't.
We do. We do. We do.
I mean another day to get ready for our test.
Maybe.
Okay, so here we go. Here's your next one. Are you ready? So here's my function. F of x is equal to the greatest integer not greater than 1/2 x, minus 1. Okay, we're gonna do this together because we only have 9 minutes and I do wanna cash our papers out. So we're gonna do the next 2 together. All right, so we're gonna do the exact same thing that we did. We're gonna talk about the transformations and then we'll go and make our graph. Okay? Always start with the transformations that you know that make you feel more comfortable. What about this guy? Do you know what this guy's gonna do? What? Right 1. Right 1. What about this guy right here? What's he gonna do?
Up 1.
Up 1. Ooh, I'm so smart. Okay? Uh-oh. Y'all, anytime they put something in there on the X, it's probably gonna be weird. Okay? And it's gonna be one of the more difficult skills. Okay? So this 1/2, is it a horizontal or a vertical transformation?
Horizontal.
Horizontal. Y'all, if it has to do with the X, it's going to do the opposite of what you think. Okay? So, this is a horizontal compression or stretch?
Compression.
Compression.
No. Stretch. It's
Yeah, y'all,
opposite.
it's opposite. It's opposite. If you took my height and you halved it, yes, that seems like that would logically be a compression, but it's with the X, so it's gonna do the opposite. So it's gonna make it a horizontal stretch.
Wait, if you say it's gonna be the opposite, when I think
It's the
of
res-
horizontal, I
Okay,
would think
now
of
listen to
X.
me.
But if I think of X, then I would think opposite, so that would be vertical.
No, I mean, the opposite is the word compression or stretch. It's not the word horizontal or vertical. Okay? So stretch, it's gonna be a stretch of whatever his reciprocal is. What is the reciprocal of 1/2?
2.
2. So tell me what that's going to do to these little black steps.
Make them longer.
That's exactly right. Instead of being one long, they're going to be
Too long.
too long. Now, y'all, it's still a function, okay? It's still a function. All right, so this guy right here, I'm starting with this guy. Okay, so I'm right here. He's solid on the left and hollow on the right. How would I flip that and make that hollow on the left and solid on the
Put a
right?
negative in front of
Where?
it.
In front of the X.
Inside the greatest integer brackets or outside?
Outside.
Mm-mm.
Inside.
Outside is gonna reflect it over the x-axis and it's gonna take it and do it like that and make it go down, okay? Inside is gonna take it and flip it over the y-axis, which is gonna do that, okay? All right, so very good. All right, so I'm right here. I'm gonna go right one. So that little solid dot is now right here. Are you with me? What is this plus one gonna do?
Up one.
So now he's gonna go right here. And this horizontal stretch of 2 is gonna make him go all the way to here. Are you with me? Yes? Okay, where's the next one gonna be?
Up one.
And 2, okay? Down,
They look like golf clubs.
Sure.
Travis, you didn't even play. Be quiet.
and that's what he looks like. Everybody okay?
Movie one A.
Here's the next one we're gonna work really quick. You try and do this one. Write your notes out there just like I did mine, okay? Write your notes out there just like I did mine.
Ich habe keine Ahnung, was das ist.
I'm passing papers from the back.
1/2 it.
So plus 2. That means I don't know a lot of this. See, it's never good when you write on a problem. Be careful.
Because it has a negative slope. I told y'all negative slopes are dangerous. Okay, so let's look at this guy. This is gonna take him where?
Left. 2.
Yeah, left 2.
Left 2. This is gonna take him where?
Down 3.
What about this guy right here?
I don't know.
A vertical what?
Stretch.
Compression of,
I'm not stretch.
half.
That's what I meant, but.
okay? The vertical is the number. That means that instead of my little steps being 1 apart, they're baby steps. They're
Half
just gonna be a
apart.
half apart, okay? So here he is. He's gonna go left 2, 1, 2, and down 3. 1, 2, 3. So he's right here. And he goes over 1, then he goes up a half. And over 1. And up a half. Yes, just for me. Little baby steps.
Wait. Up a half over 1.
No.
I'm taller than you.
Oh,
Well,
no, she
obviously,
was taller.
evidently that's not saying much, so. I'm 5'2". I used to be. I'm probably at the age now I'm already shrinking. I don't know.
Oh, I forgot. Yeah, you shrink when you get older.
Yeah, you get
Miss
shrinking.
Davis, what if like your husband catches up to you and like shrinks like? Okay.
He shrinks faster than you shrink.
No, he's not gonna catch up with me. Unless he like me, cut his legs off.
Do you want me to hit pause on the video?
Okay, yes. Anybody got a question? Okay, yes, thank you, Eli.